So let me get some gloves first.
No, what I'm saying is like then it is easy actually. That's what I was thinking of.
Yeah. I mean, the sample prep is easy, right? You just put it on the pan, but you have to make sure the pan's clean, and then everything else is good to go, and then you tear it out. The tearing will actually be done right here on the touch screen, because you can tear multiple ones at the same time. Yeah. So, all right. So the first step to prepping a sample, of course, is to wear gloves. You don't want to contaminate your sample or the pans. So, essentially, you want to take one pan, and like I said, if they are in this Petri dish, I generally assume that they're clean. However, it may be a good idea to give it a quick pre-cleaning before you start anything. So I'm going to rest the pan right here. I'm going to get me first a little bit of solvent and cotton swabs. Okay, so I have some ethanol and a few cotton swabs. So what I'm going to do is essentially dampen the cotton swab with some ethanol. Right? And what I'm physically going to do is sort of move the cotton swab around the bottom of the pan. Okay? Of course, if you see any residue come off on the cotton swab, you know it's definitely dirty. If you don't see any residue, then generally whatever is on the pan is likely going to stay there. So try not to press too hard when you're doing this cleaning. That's what will actually bend the pan. And again, like I said, if you deform the pan, then you have issues with it being stable in the instrument. So try not to bend the pan. So try to be gentle, but make sure that you can sort of physically get off as much residue as possible from the pan before you start using it. So now that I have the residue off of the pan, my next step is to actually go and burn the pan. So we're actually going to go over to the fume hood and use our torch to heat the pan up. So we're going to go over here. Okay, so we have our propane torch here. So the way that you operate the torch, first thing, I'll just rest this down. You want to turn counterclockwise to open up the valve, okay? And you want to turn until you feel like you're tightening it. And you simply click the trigger, okay? Then you can adjust the flame up or down. I actually prefer to do it in the dark because that way you can see the whole flame. Now I'm going to take the pan in my tweezers. Make sure you have a good grip. You don't want the pan to fall. That's where all these burn marks come from because of the hot pan falling on here. So please make sure you grip the pan properly. And you want to put that into the flame until it gets nice and red hot. Be careful. Alright, and then to turn off the torch, you simply turn clockwise until it stops. There's no need to tighten, just turn it until it stops, and you can see that I won't be able to turn the flame back on. So now, do not rest this pan on anything plastic on here. This entire surface is essentially plastic. Please do not drop the pan on here. Keep the pan held in the tweezers until it cools itself down. It doesn't take very long, but you definitely want to hold it for a couple of seconds to a minute to make sure that it gets back to room temperature, okay? So now that this pan has been flamed, it's basically considered a clean pan, okay? So that now you can go ahead and use this pan. Use the solvent and the Q-tips first, and then you come in and flame it. When you flame it, make sure that you do not add any extra solvent or any extra anything. Flaming it is always going to be the last step, and that's going to make the pan properly clean. If you do anything else after you flame it, of course, solvent and other things can leave residues. So the flaming part has to be the last step. So now I'm going to take this back over. So now, basically, this should be cool by now, and I'm basically going to rest it on my selected sample position, and it actually goes in a very specific direction on here, okay? So, oh, you got to put the other side in there. This side is not in. See? Just drop it. Yeah.
This is like this. It's not long.
Are you recording or not?
No, you can just start it, yeah.
On top here, a little bit. Because they have to put this in a specific position.
Oh.
So. Are you good?
Yeah.
All right. So, you recording?
Yes.
Okay. So, the pan actually has to fit squarely like this onto the autosampler. As you can see, there are these two side grooves right here on the right and left side, and those actually correspond to those little pieces at the bottom of the pan. So that must sit within those grooves for it, oopsie, and for it to lay straight on the autosampler. If it is not laying along those two grooves, then the instrument will have a problem picking it up. Okay, and again, of course, if it has a problem picking it up, you can spill things. So make sure that it's laying nice and flat within the circle and along those two grooves at the bottom. Okay, that's the only way that it can fit on the autosampler for this instrument to pick it up properly. Which again is also the reason why you should not bend or deform these pans, because then you won't be able to do that, and you will have issues. The instrument will have issues picking the pan up from the autosampler. All right. So now that the pan is on the autosampler, we can go ahead and tear the pan. Okay. So what we can do here, we can simply go onto the touch screen. All right. And you have a button that says tear. So you tap that button. I like to select and deselect all, just to wipe everything that was there before. And right now, I am on position 20. So I'm going to tap 20, and it should turn light blue. Okay? Now, the advantage of this is that I can tap other numbers on here to be tiered, and it would tear all of them in, one after the other until it's all finished. So as many of them as you highlight is as many of them as it will tear. Okay? And all you would need to do at this point is hit tear. And as you do that, you will see the screen says about 2 minutes estimated time. That's because it's now going to open the furnace up, place the sample inside, and tear the weight out. So tearing is essentially like you would do for any other standard benchtop scale. You're basically zeroing out the mass, right? And like I said in the beginning, there is a reference pan. So what this is essentially doing is zeroing out the difference between this pan and the reference pan to give you a number as close to zero mass as possible. Okay? As you can see, the sample is now suspended on the hook itself. Again, you should not have to put your hands anywhere in here. This is all automated. You're just putting it on the auto sampler and letting the instrument do what it needs to do. Okay.
So if there's anything happen, for example, the hook didn't pick
If
up,
anything happens, just press stop.
stop. Okay.
Right. If you see anything strange happen, hit stop immediately. It will stop exactly whatever it's doing.
And then reverse it.
And then you come get us to make sure that if it's something is spilled
Okay.
or if it fell in there, we need to know. Okay. Also, if you spilled it on the auto sampler and things like that, and you have a bunch of other samples on here, you may want to remove your other samples, clean out the auto sampler. This actually comes off, so we can come off and clean it out for you, things like that. Again, generally, as long as you don't deform the pans when you're cleaning them, there shouldn't be any issue with the pan not being able to be picked up or anything like that. Just make sure you're taking your time to do everything and placing it properly on the auto sampler position, and nothing should really happen. Okay, but if it does, hit stop, come get us. Let's make sure that we evaluate everything properly, and then we can tell you whether you can continue or not. All right. Another word of advice: once this instrument is running, this entire table is off limits. As you can see, the pan is simply suspended in air. There is no other real support. So any little bit of vibration is going to be transferred into the sample, which will be transferred into your data. So if your pan is tearing or you're actually running an experiment, this table is off limits. Don't touch anything on the table to cause any unnecessary vibrations into the instrument. Okay? All right, and you can see now our pan is teared. It's now out of the furnace. So what we can do now, we can hit back to get back to our standard screen here. So now we're essentially ready to place our sample in the sample pan. So first I will get some a piece of weighing paper. So I'll take a piece of weighing paper and place it right here. And I can take up my sample pan, place it on the weighing paper, and now I can load my sample on here. So if I have a powder or anything like that, I can scoop some into the tray. Make sure that your sample is relatively flat on the sample holder. If you have films and things like that, make sure to cut them properly to size. You don't want to cut them larger than the diameter of this pan. The reason is the furnace is only slightly bigger than this diameter. Okay, so anything that can accidentally touch the furnace, again, that would cause a lot of noise in your data. It can cause other issues as well. So everything must fit inside the pan, not outside, hanging off the edge, nothing like that. It must fit inside the pan. Okay, try to make your sample as even as you can get it, and that's basically the way you want it. All right. And of course the weighing paper is here to keep things clean, to catch any residue or anything like that, so that you can keep the area as clean as possible. Once you're finished, again, pick up your sample, place it back on the correct position on the auto sampler. All right, and now you are ready to run your experiment. Now you can go in and hit start on the software, and then it will automatically take the sample in and run the experiment. So the start button is right up here. And once you hit start, of course, I'm not going to do it right now, but once you hit start, it will then take the sample, carry it back into the furnace, close the furnace, and start the experiment that you're running. Okay?
For the sample, as long as the sample can fit into the pan, then it will be fine.
Yes, as long as the sample can fit into the pan, that's fine. How much sample should you put in there? I generally tell people to aim for about 10 milligrams of sample. Reason being, I don't want you to fill up the pan in case, for example, your sample degrades in such a way, and I've seen this happen before. If your sample produces a lot of gas while it's degrading, sometimes that can cause the sample to foam and bubble up, in which case that's an issue. I would say generally most samples don't really do that, but there are some samples, like if you are testing foaming agents and blowing agents, that's exactly what they're going to do. So you want to be careful with your masses. But in my experience, if you get to 10 milligrams, the noise level is very nice and low, your data is very reproducible, everything's nice and consistent, and you don't have to worry about it too much. Now, if you can't get to 5 milligrams or you put more than if you can't get to 10 milligrams or you put more than 10 milligrams, there's nothing terribly wrong with that. The instrument is sensitive down to the microgram level, but you don't want to start with micrograms of sample. Okay, so you still want to start with a good amount of sample. The other thing is, if you're running multiple samples, it's a good idea to stay within a nice mass range. So if my first sample is 17 milligrams as opposed to 10, that's okay. Your next sample should be somewhere in the range of 17. So if you hit 17, you want to stay within about plus or minus 5 milligrams of that. The reason being, again, that can affect the data that you see, that can shift your data, especially for materials that may have the potential to sublimate. The sublimation would happen faster with less material, and it'll happen slower with more material. So that'll actually start shifting where you see these mass losses occur. So if you stay within a nice mass range of your first sample, then or whatever the lowest mass of sample you have, try to navigate around that versus navigating around the largest sample, because that way you won't have such a large mass distribution. Okay, that again just helps to make data more consistent, so that when you're overlaying things and you're looking and you're comparing two sets of data, you don't have too many other things to worry about. Okay, but in my experience so far, doing 10 milligrams of sample, if you can get to 20, great, get to 20. That they work just fine. You shouldn't have any issues with noise or inaccuracies at all once you get to that number. But it's very capable of running to less than 10 milligrams with very little issue. So if you don't happen to have that much, that's not the end of the world. You can still run it and still get very good data. Okay. So yeah, so that's basically the end of it. At this point, once you hit start, it's just a matter of waiting for your sample to go. So what I'll just show you now is an example of what some results may look like. So I'll go into the results tab. And by the way, when you hit start, it will automatically go to the results tab and give you a live data feed of what you're running. Okay, so you can basically watch your data get recorded.